All right, so class, you might notice by now that I am out. I'm going to be out all week this week. So I have a series of video lessons that you're going to be watching to both look at solving and writing inequalities, as well as some exponential work, which you'll see later on in the week. So our objective today is to solve and write inequalities or equations and identify the variables. And by variables, I'm referring to the dependent and independent variables within a scenario. So we're going to start by doing some equations or classwork together, and then you will work independently, and you can work with a partner, with your table mates for your independent work. But for your exit ticket, I want you to do that by yourself, and that will be collected at the end of class. So we have this first situation or scenario. And back when you used to rent DVDs instead of just get it on Netflix or, Hulu or wherever else you watch most of your television, you could rent a DVD. In fact, Netflix used to rent DVDs. And for instance, in this situation, the company charges $95 for a membership and $5 for renting a movie. So $95 for a membership and $5 for renting one movie. You might not be able to see this part here, but it says you have $125. So this is the total amount that we have, or you have. You want to write and solve a mathematical equation or inequality for the maximum number of DVDs that can be rented after purchasing a membership. So first of all, we're going to take this membership into account, right? And that's a part of this $95, so that we can't just simply ignore that. So we have a couple of things. One, we have a flat fee. And I'm just going to move down here and use some space down here to write an equation for this particular situation because I'm going to spend all of the $125. I'm using that as the total amount that I have, and I'm going to just spend it all. So I have $95, right? I'm starting off, that's how much I have to pay. Plus, I have $5 for each movie. So let's say let M equal movie. So 95 plus 5M equals 125, which is the total amount that I can spend. So now that I've written my equation, I could go ahead and solve it. But before I do that, I want to go back to this part here. It says identify your variables. So we have our independent variable and our dependent variable. The independent variable is sort of the x, right? It's the x value. The dependent is the y, and the x is the bossy variable. It determines what happens with the independent one. So what is determining what here? Well, I want to look at this sort of part of this scenario. And from that, I'm going to determine what my two variables are. I have money, right? Right, that $sign, $5, and I have movie. So if I have money and movies, or cost and movie, what happens? Who controls what? Well, I know that if I rent one movie, it costs $5. If I rent two movies, it's going to cost $10. So the amount of movies I rent is what determines how much money I'm going to spend. So the movie is my independent, or I don't know, I'm just saying movie here. You could probably say something else, video, DVD, number of DVDs, say number, and the total cost or cost is my dependent. And I got that just from this one particular part of this situation. So we already have our equation. I know you guys definitely can do multi-step equations. So I'm going to go ahead and solve it. Right, we're trying to isolate our M, get it alone on one side. And I'm just going to bring it over here. 5M equals 125 minus 95 was 30. And I divide by 5 on both sides. M, or the number of movies, is 6. So in this situation, what is a viable solution, and explain why it is a solution? Well, it's a linear equation. unlike quadratic equations, I only have one solution in this situation, right? I have m equals 6. It doesn't equal 6 point some decimal. It doesn't equal, 5 or 4, a range of numbers. It only equals one number. So I would say, and I'm going to type this, there is only one viable solution. And viable just means it works. Viable solution. And that is, I can rent 6 DVDs, right? And that's the solution. Or I can even add another part that says, or m equals 6, right? So which one is not a viable solution? I must have put that down there before. Identify a non-viable solution and why it is not a solution. Well, if m equals 6, and that's the amount of money I have for that, then 7 wouldn't work, right? So I would say a non-viable solution, and there's a lot of options, would be 7. 7 DVDs, because I don't have enough money for 7 DVDs. Wow, my typing is horrible. Another non-viable solution would be 1.6. Or not 1.6, but 6.1. Because you can't have a fraction of a DVD. And if you do, there is no value to that DVD, right? So these two they both explain what a viable solution it could be is in this situation, and what a non-viable solution is. Both of them would be, I would definitely agree with those. All right, so now we have another situation, and this is the last one before you do your independent work. You have a car rental company and charges $35 per day and a one-time rental fee of $50. You can spend no more than $250. Write a mathematical equation or inequality for the maximum number of days that you can rent a car after paying the rental fee. All right, so in this situation, I have so slightly different than the one before. Again, I have a flat fee, right? And it sort of says this is my flat fee of $50. And I have $35 that I am charged per day. Okay, so again, this is going to be a particularly important one when we try to find our independent dependent. But what's different, it says instead of before where it says I'm going to spend exactly whatever 125, I can spend no more than. I can spend no more than 250. So you could probably look to the back of the classroom and notice that we have those inequality symbols near the back that sort of point to when you have greater than, less than, or greater than or equal to, or less than or equal to, right? So no more than tells me I'm going to have some type of inequality. So let's start by writing down, in fact, we'll do it a little bit different. We're going to start by identifying our variables, and then we're going to come back to writing our inequality. And so I'm comparing dollars, right, cost per day, right? So what controls what? Well, the day, the number of days I rent the car, controls my total cost. Right? So if I rent it for 1 day, it's $35. If I rent it for 2 days, it is $70, and so on. So let's go ahead and write our inequality. We know that we start with 35, times what is our variable? Let's let D equal days, or number of days. So 35D plus a one-time rental fee of $50 can be no more than. So that means that this part here has to be less than $250. But can it also be equal to? Well, let's see. I can spend no more than $250. So that means I could spend $250, right? Yeah, I could. So I'm going to do less than or equal to $250. All right, so I'm going to move this sort of slightly out the way and bring this back. Oops, can't move it. Oh, well, that's okay. So I am going to now go ahead and solve this inequality the same way we would solve an equation. I'll just write it again over here. And I want to isolate my variable, so I want to keep that D, or the 35D, by itself on that side. And then I have 35D, and now I want to divide both sides by 35. And here I have D is less than or equal to, so let's see what that turns out to be. 200 divided by 35. So I have 5.714, etc., etc. And I want to just, well, I'm talking about days here. So I want to probably just round it to the nearest tenth. So I have 5.7 days. Okay. Now, if it were money, I'd probably round it to the nearest hundredth, because we still have money that deals with hundredths, but we really don't. We could have a fraction of a day, but so this could possibly work. It depends on if they charge fractions of days. And we've talked about that, or we could talk about that again when we talk about discrete or continuous functions or variables. So I have 9. So I just have my solution here. So I want to go ahead, and what I didn't do the last time because it was an equation, but I can do it now, is I want to sort of graph what that looks like. So I'm just going to draw my number line. And I have, let's say, 5, and then I'll do 6 and 4, etc. And D is less than or equal to 5.7. So let's say 5.7 is right around, I'm going to say here. All right, and so I'm going to include it because it does have that bar underneath the less than symbol. I'm going to include it. And then all the values, and I'll just change the color here to show. All the values that are less than that are included. So a viable solution. Well, a viable solution, I'll type this. Unlike before when we only had one solution, we have a range of numbers here. So I would say 5 is a viable solution. Let's see, 4 is a viable solution. 3 is a viable solution, right? So there's a range of numbers that would be viable solutions. 0 would be a viable solution, right? If you decide that you don't want to rent the car, but you might get stuck with this $50 rental fee. I don't know, it depends on how they work. So I would say 0 to 5 or 5.7 are viable solutions. And why did I stop at 0? Well, do we have a negative day? Can I have a negative number? No. Well, I can have a negative number. I can have a negative day. So, so anyway, your viable solutions are going to range between 0 and 5.7. And you can list any number from that. You can say, well, 3 is a viable solution. I only want it for 3 days. What is a non-viable solution? Well, I'm going to say -2 is a non-viable solution. Because, yes, it is less than 5.7, but you cannot have a negative day. It doesn't work within the context of our problem. You can have a negative day, but not a negative number day. So it does not work within the context of the problem, which is, or a variable, which is refers to days and total costs. So now after you've watched these videos, or this video, you're going to go ahead and do the classwork and then complete the exit ticket.